So my name is Seema Ramchandani. I was on Silverlight Performance for about 2 years. I've moved on to graphics. I've worked on controls, and I have a couple of tips and tricks on how to build an optimized application. The question is really, why are you here? And I often get an email, something sort of goes like this. I'll give you an example. When we were in the WPF team from the 3D, I was as the 3D PM, I got an email that said, from the performance team, hi, the newsreader team has built an application that just displays text and lays out the text nicely. And for some reason, we profiled the application. It's taking up around 80% CPU. We don't know why. They say that they're not doing anything. They swear that they're not doing anything in the background. And it turns out that the 3D pipeline is getting presented. And so that was just weird. So we went through and we debugged the application. We removed layer after layer of the panels. And we slowly uncovered a giant 3D dancing bird. So what had happened was the designer had developed this sort of icon or embellished their application with this 3D dancing icon. And then they decided that it was really ugly. And then they moved it to the back of the Z order, correctly assuming that WPF doesn't actually present anything that is hidden in the back of the Z order. What they didn't assume, and that's true for Silverlight as well, what they didn't remember was that all of the animations to calculate the next dance move of that bird was actually pretty expensive. And so while we didn't see any visual changes, there was a hidden dancing bird in the background. So I'm here to talk about 3 things. Yesterday we talked largely about the drawing pipeline, and how many of you guys were actually at yesterday's session? Q? Okay. So for those who haven't, I highly suggest watching yesterday's talk online. It'll be available for like the next 2-3 years. Everything I say is permanent. I'm going to talk about the media pipeline, briefly walk through profiling and debugging your application, and then tips on tricks on how to build an application. So when building an application and trying to do something sort of, I think, games or snazzy, or you want like almost immediate user feedback, often people are going to be writing code that occurs on the UI thread. In fact, all of your user code is on the UI thread. What is also on the UI thread is your animation system, your control code, and our layout system. So almost everything managed, and then a little bit of the unmanaged stack as well. What's off the UI thread is frame rasterization and media decoding, and anything harnessing the GPU. What this means is if you are doing something like I'm executing a query offline, and I'm building a huge visual tree, and in the meanwhile, I want to show a little splash screen that's animating in the background, turns out that that splash screen will not be animating because you're doing so much work on the UI thread. So on older browsers, this means one UI thread for the entire browser, all tabs. On newer browsers, we're starting to see one process per tab. So keep in mind what's executing on the UI thread at all times. Let's jump into media. One of the key things about media is we have lots of optional steps. So we can start off with media decoding. We then go into the YUV convert. If you resize your video, then we're going to do that as well, and we'll do an interpolation for every pixel. If you do the blending, if you animate in your progress bar, if you do something like you have semi-transparent video in the background for like some cool effect, we'll also do a calculation of the multiply for that every pixel. And then we present to the screen. Now, if you harness the hardware pipeline, the last 3 steps will actually be done by the GPU. But there are cases where you're going to be falling back to software, like let's say you want an effect or projection. That will be done in the software. 3 tips. So encode at the minimum frame rate that you need. So if you don't need all those frames, if your users are seeing this video almost in the background, it's not actually the primary point of your application, try to downgrade your video to around 18, 20 frames per second. It'll just be less cost over time, and your application can actually harness or can target a wider variety of machines. The second thing is software. For software, encode at the desired size. For hardware, it doesn't make so much difference because we're actually letting the GPU do the stretch, and the stretch is almost free now. But decoding the video is per pixel, and so is the YUV convert. That's per pixel. And so hardware, software, always try to use as minimum cycles as you need. This is really pretty basic stuff. And of course, blending is expensive. Let's talk about profiling. We have to move a little bit quickly in order to get Q&As. So I have, actually, let's show this slide first. A couple debugging tips that I walk through on my blog. The first one is the windowless plugin. How many of you guys use, excuse me, how many of you guys have used a windowless plugin within Silverlight? Okay, a couple of you guys. What windowless does is it can do either of two things. It can either show browser info in the background, or it can show other browser HTML content on the top. If it's on the background, then that means that we're doing 3 extra steps every frame. We're asking the browser for what's in the background, and then we're actually blending with that calculation. And each browser handles that differently and with different performance. And so it's very important to test widely on different OSs and different browsers when you're using windowless. So when debugging, I tend to actually turn it off to reduce the variance. If it is true, you want to make sure that you have less transparency, not have an alpha channel in the background. Frame rate is a great debugging tool. In software, you can actually max out the frame rate to 1,000, 10,000. And if you're inserting like a effect or a projection, you want to see how much impact it has on your CPU cycles. Most of us are actually profiling on high-end dev boxes or designer boxes. And so an easy thing to do is max out the frame rate and see how much it drops down based on whether the effect is included. In hardware, that will be capped around to the screen refresh rate, to 60 frames per second. 2 other debugging settings. The first one being enable frame rate counter, which will show in the lower left of the status bar. It will actually show your frame rate and how often we present to the screen. And in hardware, it will actually show how many textures are actually displayed and how many textures are created. So if you're trying to debug a memory problem, it's a great little debugging tool. It's ugly, but it works. And then, of course, enable redraw regions. And the best way to look at redraw regions is to look at it directly. So I'm going to mute this so you guys don't have to hear it. So this is a video that was encoded with expression encoder 1. It's just a default template that they output. And it looks pretty harmless. Like you have the thumbnails animating in, animating out. You have this progress bar that animates in and animates out. Sure, blending can be expensive, but this progress bar is pretty small. If I actually turned on enable redraw regions, I can see each update done to the screen. And so, of course, when the video is playing, that entire area of the plugin is drawing. If I animate in the thumbnails, I see only the area that's actually being drawn. Notice that on the right, we're actually doing some blending and doing some redrawing in areas that are not actually getting an update on the far right corner. And then the progress bar, which we thought was harmless, is actually updating the entire screen. It turns out that there's actually a canvas overlaying the entire video to display that progress bar. And you can optimize that by simply minimizing the size of the progress bar. So when keeping in mind performance, it's basic stuff, right? Minimize the size of your objects, minimize the number of operations you do per draw, and then, of course, try to profile it at the end and see what your constraining cycles are. So that's enable redraw regions. It's a very simple tool. I don't suggest using it if you're epileptic, but it works. A lot of us get emails from customers saying, hi, hi, your app, the app that you wrote, it's taking up 100% CPU. And you're like, okay, well, how did you determine this? Oh, well, I ran it in IE, and it's slow. Well, okay, that's not very useful information from the, you don't know what toolbars they have, you don't know what games they're playing in the background, you have no real idea. So Xperf is a tool that the Windows performance team had written a while back, and we use it internally, I think for the last 10, 15 years, and it just got recently released about last year. It uses the event tracing for Windows mechanism, which logs events for both user and kernel level code, and it allows you to actually see the breakdown of where CPU cycles are spent in every line that you have a symbol for. This analyzes your unmanaged call stack. It does not actually profile your managed code. If you have a need for a managed toolbar, then I highly suggest, a managed profiler, then I highly suggest emailing us, posting your scenarios to the forums so that we can gauge the customer impact and push it to a higher priority. Of course, all of the features that we do with Silverlight in the tools is based on customer user feedback. And so if not having a managed profiler is a problem for you, please let us know. So I'm going to start with Xperf. Yesterday I did I have 3 minutes left, so I'm not going to actually profile this live. But basically, you turn on the profiler, you run your application, and then you turn off the profiler. And I walk through the command line steps to do this on my blog. You then can see a graph of how the application performs over time and everything else in the scene. You can see how the desktop window manager is doing any Windows, any Microsoft component. It's split over the 2 CPUs within my, the 2 cores within my machine, which is why you see 2 lines. I load in my symbols. All Microsoft products, or at least most of them, actually publish their symbols for their platforms. And so this allows you, if you connect to our symbol server publicly, you can actually look at the breakdown of which DLLs and which actual functions within Silverlight are being spent the most time. So this was a profile of the application that we saw earlier with Halo video playing. The top issue is actually doing a stretch. You see that it's 16% of the time is spent actually in AG core, AG silver core. Okay. So 5% of that time is actually doing the stretch. That's actually 30% of your overall CPU cycles. So yes, very little on this machine, maybe a bigger percentage on your lower end user box. We're doing the YUV convert to RGB. This is a small video. It's taking up very little CPU. If you actually have a bigger video, that encoding from YUV to RGB is actually more expensive. And then you can walk through. Xperf gives you the ability to get exact numbers. It allows you to tell if your application is causing Silverlight to spin. We don't have any documentation around what functions are doing which item, but if you post them to the forums, most of us can actually answer the questions. It can decide which layout and design is more expensive, whether your UI virtualization actually has made an impact, whether the scrolling is actually whether scrolling is the problem or whether creation of the objects is the problem if you have a virtualized list box, things like that. How much is that new feature, how much is that progress bar going to actually cost me? And then the breakdown of the time spent. So one of the things that we saw customers actually running into issues with our stack when they were profiling was that we were spending a lot of time in our text stack. And you can do this via text block, text blocks, or even glyph. And the text stack was written for cross-operating system consistency. So we have our own internal way of displaying our text. And we optimize the rendering for legibility, which means that we do 3, 4 steps for actually every time that you move the text onto a different pixel location. So we do anti-aliasing based on the pixel location, the horizontal and vertical dropout to further refine the glyph, and then gamma correction. And actually, I think we announced a couple of other text enhancements in Silverlight 3, which all are going to make it a little bit more expensive. If you're scrolling text, if you're animating text, you'll often see that text is actually one of the harder problems in Silverlight 2. And so in Silverlight 3, we introduced this feature, which is an inherited property. You set it at the top, and it actually allows you to optimize your pipeline for actually rendering for animating text. So I wrote an app to highlight the problem that we have with text. So you can see that the text, although this is very little text, it's actually it's bouncing around because we're pixel aligning, right? So we're aligning to the closest nearest pixel. And we're also doing probably a whole lot more work than we want to, and it looks terrible. I'll be clear here. It looks terrible. So then if you actually turn on the text rendering mode new to Silverlight 3, it actually gets rid of all those legibility the optimized for legibility and turns on an optimized for performance. And you just turn it on your parent panel, and everything looks a whole lot smoother. And this is without hardware. This is without anything else. This is just simply a disabling of the more complex rendering stack. Oh, look, I'm playing this in the background. That must be fun, too. Look at how well Silverlight performs. OK. I'm going to run through these. So basically, remember that there's a unique tree for each control. And so you need to understand what is in your XAML. So when working with designers and developers are working together, make sure to set goals together. Because if the designer is expecting maybe to use 100 vector objects per rows, and the developer is expecting maybe 2, then we have a little bit of a problem if we're going to have a catalog of flowers. So make sure to set goals. And the way to set goals is basically how many objects on a page, how many controls, and then think about elements, states, storyboards. You can start prototyping without having written all your custom controls. You immediately know, I'm going to have 100 controls. Let's try it with 100 buttons. And then prototype. Less is more. Karen's going to go through controls later on. But basically, define your startup goal, prototype, and watch for bloat. Tools cannot guess your usage, and so it's always important to look at what your tool is outputting, right? Blend has fixed the problem with the higher number of decimal places. But we once got an application sent to us that was basically a couple hundred megs of XAML. And it turned out that the way that the designer was using the tool, they were basically copying and pasting splines that were sometimes used for animating this little character. And some of the splines were never used. And so they got, huge problems with bloat, right? Like they were never looking at their XAML. They were never realizing whether there was bloat. And so make sure that you can always email your source. So with that, I'm going to basically, there's a whole series of blogs. I always have performance tips, and I always have a few more little additions, tips and tricks. If you ever have a problem, please email me, and I can go ahead and figure it out with you. And then we can step back and say, well, how do we publish this for the greater good? So I love debugging apps, and I love helping figure out how to document it better for the rest of the team, or the rest of the world. So with that, I'm actually out of time, but thank you very much. So we have no time for Q&A, but feel free to contact me via my blog and also fill out the speaker evaluations. Thank you.